Hello, welcome to the Introduction to Finite Element Analysis. Finite element analysis is a very interesting subject. It should be known by every engineer. It is applicable not only in mechanical engineering, it is widely used in different areas in science and technologies. So what we are going to learn in this finite element analysis? In simple way, we are going to tell you what will you learn in this course is basically the theory of finite element analysis as method applied to one-dimensional problems. That's we're going to deal with the first chapter. Then later we go for two-dimensional problems and as well as the three-dimensional problems. So you will understand how the complex geometries are broken and how they are discretized and how they are assembled and how we are going to write the assembly equation, and also we are going to learn about or lot of stuff about terminologies, how we are going to use this technique in different applications, and also we are going to learn how to apply boundary conditions, initial value problems and boundary value problems, and mostly different mathematical approaches for this method. So, what are the different mathematical approaches? Since we are using ODE, PDE and integration. So, these are the major term for finite element analysis. We are going to study about ODE, PDE as well as integrations. And I think you might have a good understanding of one-dimensional problems. Then going from that to two-dimensional problems is relatively very easy. That is not a big term. And most probably it is a conceptual, and also you know how to use this technique, and also you're going to understand this context of finite element analysis in one-dimensional problems, two-dimensional problems as well as three-dimensional problems. So we don't think too much about one-dimensional problems are easy, two-dimensional problems are complex, and the 3D problems are super complex. So what I'm trying to say is, if you learn the concept of one-dimensional problems, then it is easy, relatively easy to apply the concepts in two-dimensional problems also. The major addition in two-dimensional problem is assembling the elements. If you have one-dimensional problem, you analyze only one element. If you have two-dimensional, then there will be two elements, then it is easy to analyze individually and then you are going to assemble. That is called as global stiffness matrix. So that is a major difference. Other than that, we start from one-dimensional, then we move to two-dimensional problems, and later we move and discuss about the 3D problems. In general, how this finite element analysis works. And what is finite element analysis? Where are we going to use? Finite element analysis is now very extensively used in almost all areas of science and technology as well as engineering. You can be a mechanical engineer, or you may be a civil engineer, or aerospace engineer, or you can be a material scientist or physicist, and you can be a chemical engineer. This method, finite element method or finite element analysis, is applied in all the areas. See, for example, we are going to analyze the pressure in the pressure valve in mechanical, and it is easy for you to calculate the climatic changes by using this finite element analysis, and also it is easy to understand the pollutants which will be available in the air, the impact of pollutants in air, lakes and sea waters. It is easy for you to calculate. These are some of the applications of finite element analysis. So virtually all areas of engineering and science in some forms or other, maybe FEA is used. So the FEA is used wide areas. Why they are using FEA is, it is easy to solve the complicated problems, and also by solving the complicated differential equations. That's why the scientists and most of the industries are go for finite element analysis. How they are using how they are useful for complicated problems. If you have the known structure, it is easy to analyze. So this is a known structure. It is easy to analyze. If it is an unknown structure or unknown boundary conditions, and it is tough for us to calculate. In those cases, finite element analysis will be very, very effectful and useful to calculate. Why? Because it is mostly general, most in general, and also it is very flexible to do the calculations and perform some operations, which means equations. To calculate the displacement, stress and strain values in structural, non-structural problems. In other way, we may call it as linear and non-linear problems also. Not only in these structural problems, this might helpful in thermal problems also, and also steady state, eigenvalue and time dependent problems also. So it is widely used. So how it works? So with the help of the PDE, ODE and integration, finite element analysis works. Finite element method may explain or may define in different techniques. So day to day, due to the advancements in finite element analysis, it may change. In general, it is a numerical technique to find the approximate solution to the boundary value problems. So what is the term here? Approximate solution mentions. So approximate solution is nothing but, so since we start analyzing, there will be error. If it is an exact solution, the error will be 0. But for approximate solution, the error will not be 0. But we need to minimize the error by adding some terms, by adding the weighted term to the analysis or structural equations. Then we are going to minimize the error. So that is called as approximate solution. Since I have taken this structure, since it is a structure, it is a pen, I want to apply the load on this structure. So I fixed at the one end and leave free at the other end. So here there is no displacement because it is fixed. If I am going to apply the load on this side, then this structure will deviate or deflect from its original shape. Okay, like this. If you want to analyze the deformation at this point, it is easy for you to analyze. If you want to analyze the deformation at this point, or this point, or this point, or you may divide this structure into equal number of smaller elements. It is possible. It is possible by means of discretization. That's why FA is very, very useful. You may calculate the value even the point is 0.001. So, industry peoples are mostly encouraging finite element analysis. So, whatever the problem may be, either it may be a realistically it is easy problem or complicated problem. The element is splitted or discretized into equal number of smaller elements. Then we apply the load and it is easy for you to calculate the displacements, and as well as with the help of the displacement we are going to calculate the stress as well as strain value. And let me tell you the basic steps which will be involved in the finite element analysis. The first step is discretization. Whatever the shape or whatever the structure you are going to take, first we need to discretize this element into equal number of smaller elements. The next one is selection of approximation of functions, which means approximation of function in the sense we are going to give a polynomial expression, polynomial term, or else we may call it as trial function. It only defines the unknown parameters. And next, for whatever the element you should take, you need to write the element stiffness matrix. The third step. And once you form the element stiffness matrix for each element, at the end you need to club all the element stiffness matrix equation, which is called as assembling. Then finally you will get the global stiffness matrix. So formation of total element stiffness matrix is the fourth step. Once the element stiffness matrix is over, the general finite element equation for FA is F equal to K into U. Here the F is mentioned as force and the K will be the stiffness of the structure and the U will be the displacement. Once the stiffness matrix is ready, then we move on to the loading conditions. This is the fifth step. And next, the formation of overall equilibrium. So apply all these values in this given F equal to K into U equation. And finally going to apply the boundary conditions. So at this structure, so the boundary condition of the structure is it is fixed at the left hand side and right hand side it is mobile. So here x equal to 0, x equal to, let me take this value of the structure is 10, 0 to 10. So 0 and 10 here. Now the displacement starts from here to here once we apply the load. So here it is arrested, completely arrested, so there is no displacement at all. So x equal to 0 as well as u equal to 0. Here x equal to 10, u equal to, we don't know that, we need to calculate the u2 value. And apply the boundary conditions. And finally, we will get the nodal displacements. Then the final step is interrupt the results. Interrupting the results or calculations of stress, strain, and deformation will be calculated. These are some of the basic steps of finite element analysis. And what are the phases involved in this finite element analysis are, the first phase is pre-processing, whereas we are going to divide the geometry or discretize, and also we give the material property and boundary conditions. And next property or next phase is solution, where we are going to generate the governing matrix equation and applying load conditions to get the defined values. And the final step is, or final phase is post processing, where we get the solutions or the validity of solution generated, or examination of the values of primary quantities such as displacement, stress, as well as strain. So these are some of the steps and phases of finite element analysis. And what are the major advantages of finite element analysis is, it can be easily used or easily analyzed the complex geometry problems, okay, complex geometry, non-linear problems, and also vibration problems, heat transfer problems, and also fluid mechanics problems, okay. And how can we handle this complex geometry? First, by divide with the help of the nodes and by splitting the elements, and the third one is time or frequency method. Based on these three, we may easily calculate the complex structural problems. And also we can use the heat transfer problem also. That is the major advantage of the finite element analysis. So what are the software packages which is used for finite element analysis is mostly licensed softwares like ANSYS, Nastron, Abacus, LS-DYNA, Hypermesh, CATIA, and ProE, SolidWorks, the Cosmos. These are some of the software packages which is used for finite element analysis. And interestingly, Introduction to Finite Element Analysis, authored by J.N. Reddy. I mainly rely on this book only. Why? Because J.N. Reddy, Dr. J.N. Reddy's book will not compromise on mathematical terms, mathematical expressions, but also it is easy for engineers to understand the basic concepts. That's why Introduction to Finite Element Analysis, authored by J.N. Reddy, is preferable for each and every engineers. So thank you for this class. Next class we will discuss about the 2D problems. Thank you.